Welcome back to the third episode of our channel, ASA English Podcast, where we dive deep into the mysteries of the universe, exploring the unknown, the unexplainable, and the mind-blowing concepts that keep us awake at night. In today's episode, we're exploring one of the greatest cosmic mysteries out there, dark matter. It's invisible. It makes up most of the mass of the universe, but no one really knows what it is or how it works. So, what is dark matter? How do scientists study something that can't be seen or touched? And what could its discovery mean for our understanding of the universe? Join us as Alex and Emma take a journey into the unknown and discuss everything from WIMPs to the cosmic forces that shape our universe. Let's get started.
Well, so far, Emma, I have really gone diving into some pretty wild stuff. You know how we're always talking about space and the universe, right? I just read something that was blowing my mind. Dark matter.
Dark matter? Oh, one of those things scientists always bring up, but no one really explains, right? I've heard of it, but I'm not sure I understand what it really is.
Yeah, that's the thing. It's one of the biggest mysteries in science. Dark matter makes up about 85% of the mass of the universe. But here's the crazy part. We can't see it, touch it, or directly measure it. We don't even know what it's made of, but we're sure it's out there because of the effects it has on everything else.
Wait, 85%? That's more than most of the stuff we can see in the universe. How do we even know it exists if we can't detect it directly?
Good question. Scientists figured it out by studying the gravitational effects dark matter has on things we can see, like galaxies, stars, and other cosmic objects. For example, when astronomers look at galaxies, they're spinning way too fast for the visible matter, like stars and gas, to hold them together with gravity alone. Without this invisible stuff, dark matter, galaxies would just fly apart.
Wait, so dark matter is like the invisible force that's holding everything together? That's kind of wild. But how come we can't see it? I mean, how is it different from all the matter we know about?
Exactly. Dark matter is invisible because it doesn't interact with light the way regular matter does. It doesn't emit, absorb, or reflect light, which means telescopes and instruments that rely on light can't detect it. It's like a hidden force in the universe that doesn't reveal itself through regular observations.
How then do scientists even know what dark matter is made of, if they can't see it or measure it?
Well, that's the mystery. Scientists don't know for sure, but there are some leading ideas. One of the most popular theories is that dark matter could be made of particles called WIMPs, weakly interacting massive particles. These particles would have mass, but they wouldn't interact with light. They're just floating around, probably passing through us all the time. But we can't detect them because they don't interact with regular matter in the same way.
WIMPs? That's a pretty crazy name. So, they're heavy, but they don't interact with light at all? How are they even detectable if they're completely invisible?
That's the hard part. But scientists have come up with some pretty clever ways to try and catch a glimpse of them. One method involves direct detection experiments, where they place highly sensitive detectors deep underground, often in old mines, to shield them from cosmic radiation. If a WIMP happens to pass through, it might interact with the detector just slightly, creating a tiny flash of light or a small vibration that could be detected.
So, they are waiting for the day when a WIMP will accidentally knock into one of their detectors? It is almost like searching for a needle in a haystack.
Exactly. It's really tough because these WIMPs might pass through whole planets without interacting with anything. So it could take a long time before scientists detect something. But that's the fun part. If they find even a tiny trace, it'll be a huge breakthrough.
Wow, that's insane. And they've been doing this for years without finding anything solid?
Yep. But that's how science works. It's all about persistence. They've made some progress narrowing down what dark matter could be. But the actual particle, if it exists, still hasn't been detected. It's like the ultimate cosmic mystery. There are also indirect detection methods, where scientists look for signs of dark matter particles colliding or decaying. That could produce radiation or other detectable signals that we could catch with telescopes.
So it's not just sitting and waiting for a bump from a WIMP. There are other things they're looking for too. But why is it taking so long to figure out? I mean, if it's 85% of the universe, shouldn't we have figured it out by now?
It's frustrating, but it's also the nature of the problem. Dark matter is so different from anything we've ever studied. It doesn't interact with light, it only interacts weakly with normal matter, and it's everywhere. But because it doesn't give off signals we're used to looking for, we can't detect it directly. It's a puzzle where every new discovery only leads to more questions.
So it's not that we don't have the right technology, but that dark matter works under a completely different set of rules from everything we can observe.
Exactly. Not just invisible, more like nearly entirely separate matter of some sort, which is probably why scientists will refine and revise and fine-tune theories constantly. In fact, they believe some, such as a collection of so-called axions with their extreme small masses, or could form it of wholly unknown particle forms, of which none has been suggested at all.
That's fantastic. So the scientists are effectively chasing shadows, using the best equipment they have at their disposal, and hoping to pick up a very small clue that unravels everything.
Yeah, and that's why it's such an exciting time to be involved in space science. If somebody finally discovers dark matter, it might just change everything we thought we knew about the universe. It may even change the way we comprehend gravity, time, and even space itself.
But isn't that it? To know how the galaxies work, dark matter could hold answers to the ways the universe itself works.
Exactly. It may even be what is going to give us the secret of dark energy, a whole mystery. Dark energy, so they tell us, causes the acceleration of the universe expansion. Dark matter holds things together. Dark energy is driving them apart. They together would give an answer to most questions related to the universe structure and destiny.
Wait, so dark matter is pulling everything together, but dark energy is causing the universe to expand faster? That's a crazy balance.
I know, right? It's like the universe has two opposite forces that push things together, pull them apart, but it doesn't explain exactly how either one of them works. Understanding dark matter could unlock how dark energy works, and maybe together they'll give us a new sense of how the universe is built.
I've always heard about the expansion of the universe, but now it seems even crazier knowing that something invisible might be driving it.
Exactly. There is still so much to learn, so much to explore. Dark matter is actually not just to know the past or present, but find out what the future is going to be about regarding our understanding of the universe. If we discovered dark matter, it could turn the whole study of physics in our heads inside out.
I can't believe how much we still have to learn. It makes me want to dig deeper into this stuff. Maybe one day we'll be able to actually see dark matter.
That would be amazing. And who knows, we might see it in our lifetime. Science is full of surprises, and this is one of the most exciting ones.
I'm definitely going to look more into it tonight. Thanks for opening my eyes to how much we still don't know.
Gravitational. Having to do with gravity, a force which pulls things towards one another, particularly between things and the Earth. Example: the Earth's gravitational pull is what keeps everything on the ground. Inferred. To infer or conclude information based on evidence and reasoning rather than from explicit statements. Example: scientists inferred dark matter's presence because of how galaxies move around, even if it cannot be seen. Elusive. Difficult to find, catch, or obtain. Hard to define or understand. Example: the solution to the problem remains elusive despite all our efforts. Interaction. The action or influence between two or more things. Example: the interaction between light and dark matter is something scientists are still trying to understand. Persistence. The continued effort to do something despite difficulties or delay in achieving success. Example: the persistence of researchers is vital to the revelation of the universe's mysteries. Cosmic. Relating to the universe or cosmos, especially as distinct from the Earth. Example: the cosmic forces of dark energy and dark matter shape the very structure of our universe. Decay. Breaking down or decomposition over time. In physics, it often pertains to breaking down into more simple particles. Example: some particles may decay to smaller ones as they release energy. Theoretical. Being based on theory rather than actual practice. Example: Theoretical models indicate dark matter can consist of new, yet-to-be-discovered particles. Accelerate, to move at a faster pace or speed. Example, dark energy accelerates the expansion of the universe. Refine, improve something by adding minute adjustments. Example, scientists continually update their models so that they can make a much better case for cosmic phenomena. Unravel, to solve or understand something complicated or mysterious. Example, scientists will perhaps unravel the mysteries of dark matter in the near future. Revise, to make changes in order to improve or update something, especially a theory or a written work. Example, the scientists revise their theories of the universe based on new discoveries. That's it for today's podcast, folks. I hope you had a great time listening in. If you liked the episode, don't forget to give it a thumbs up. It really helps the channel. And if you want to be the first to hear our next episode, hit that subscribe button and ring the bell.